Okay, so this is a energy practice homework, and I've got a lot of feedback from people that were confused on this, so I thought I'd make a video kind of like I did of some of the other homeworks, so you can follow along and hopefully this helps you understand how to do these calculations. Okay, so energy equation is really the same equation every single time. It's going to be the change in energy, which is symbolized by a Q, okay? And so that means how much, and remember the triangle is delta, and it means change in, okay? And then the mass times the change in temperature, and we always go final temperature minus initial temperature, so it's possible for our temperature to come out negative. And then times C. C is specific heat. And that is just a value that you would look up on a chart. It is a property of the substance, and each one has a different one. On the lab, we were only using water, so that's why we use the same 4.18 each time. All right, so for the first one, we are going to be using that equation and plugging in the values we have. Okay, so it says, calculate the change in energy when 75 grams, so that's going to be my mass, of water, that's kind of important, drops from, so this is my first initial temperature, to 21.6, and that's my final. Okay, so now it looks like we might be missing something in our equation, but in reality, you're supposed to know, because we've used it so much, that the specific heat of water is 4.18 joules per gram degrees Celsius. And that's just a unit. I really wouldn't get too worried about that. It just is exactly the definition of specific heat. How much energy it takes to warm up 1 gram, 1 degree Celsius, or Kelvin, either one. Okay, so we're going to be solving Q. So mass, 75 grams. And then my final temperature minus my initial, 21.6 minus 31. And then this is water. So if it's water, the specific heat is 4.18 joules per gram degrees Celsius. So I'm going to simplify this. Order of operations, I'm going to subtract first. So 21.6 minus 31 equals negative. So this is negative 9.4 degrees Celsius. Okay, and then I'm going to times that by 75, times that by 4.18. Okay, so this is what I get. Negative 2,946.9. So when I look at my sig figs, I've got 3 sig figs here. This came out to be 2 sig figs. And this is 3 sig figs here. But if I look at the question that I plugged everything in, it's justifiable to do it in 3 or 2 sig figs. You could do either one. Don't forget that negative sign. Negative 295, that 6 is rounds up for 0 joules would be my answer for number 1.